Hello, everybody. Thanks for joining us today. Tim and I are excited to talk to you about overcoming voltage drop. So some of the things we're going to talk about today, first off, what is voltage drop? We're going to talk about ways to test and improve your own skills, and also your technician skills, and why these procedures are important. So before we get going, let's make sure we're all talking the same language. So when we talk about voltage, voltage is that electrical pressure, that push behind the amount of current flowing. And the actual flow of electrons is your current, which is measured in amps. You can kind of compare it to water flowing through a pipe. That's kind of how I like to look at it. But the actual current flow is measured in amps. So first off, what is voltage drop? Any cable, wire or cable carrying any kind of current always has inherent resistance or impedance to current flow. Voltage drop is defined as the amount of voltage loss that occurs through all or part of that circuit due to restrictions, resistance in that circuit. I like to always use this little pictorial on the side that shows a little child kinking off the hose, and the guy at the other end of that hose wonder why there's nothing coming out. So that kink in that hose is that resistance. And in an electrical circuit, that's measured in ohms. And the amount of flow is your current, which is measured in amperage. But one thing to remember with voltage drop, you must have current flowing to have any kind of voltage drop. That's one thing you need to get burned into your head. You have to have current flow before you can have loss in voltage in that circuit. So you don't have to go out and spend a fortune on training aids. This is one, pictured here that we designed, just a little simple homemade test fixture. Take you a little incandescent light bulb, resistor, put a resistor in line, on-off switch, 9-volt battery. Put all this into one little project box. Put you some studs on the outside to be able to use your volt leads to measure each leg of that circuit. But just a really simple test fixture that you can use. I brought one here today, just the same as that's pictured on the slide, but flip the light on. That creates your load. Again, you have to have a load to have voltage drop. So real easy, something you can do on your own. So before you even get started, though, you must set up your meter properly, your voltmeter. All service written material is written with the assumption that you know how to use a multimeter. You understand that multimeter. So make sure your meter is properly set up to read voltage before you move forward. So just start by measuring each leg of that circuit to calculate where your voltage drop is. Again, you can see in this picture here that the light is on. You have to have a load to have that voltage drop. So just measuring the negative side of the circuit, where is all my voltage drop? Measuring the positive side of the circuit, where is all my voltage drop in this leg of the circuit? Basically just showing you how you walk around that circuit to really dig down and find out where that loss in voltage is. So by doing so, we're able to locate that exact location of where that voltage drop is. Obviously, in a real scenario, in a liftgate application, truck application, it's a little more complex, but start with the basics. Really learn how voltage drop works before you really dig deep into diagnosing. It's something you can't touch, you can't feel. It's sometimes hard to grasp the concept, but use something like this to really understand how it works. And there are other training aids out there that are a little more professional. They really dig in deep on all aspects of a truck or a trailer to get you or your technicians familiar with every function on that multimeter and understand how each function works. So there's options out there for you to really understand how voltage drop works. So one of the common things that's used out there is a test light. I would be taking this crutch away from your technicians. First off, it's not going to provide that voltage reading. To do any kind of proper diagnosing in a electrical circuit, you got to have that voltage reading. Another thing is it only takes milliamps to light a test light. So it's only going to tell you if that circuit is complete. It's not going to tell you if that circuit can carry any kind of current load. If you only have one strand of wire on, hanging on, it's still going to light this test light. But if you run any kind of current through that circuit, it's going to blow that circuit out. So also another thing to point out is these tend to have a really sharp point on them, and the first thing they want to do is pierce that insulation. So that's just inviting all the toxic concoctions that are on the roads these days to intrude into that wire and cause huge headaches later on down the road with your fleet. So really understanding how to use a multimeter and eliminate that crutch of using a test light that some technicians like to use.
So first off, why do we need to look at performing electrical diagnostics? Number one, catch a problem before it becomes a major issue. Is that, what you can look at doing there is preventing, the amount of road calls that you're getting into, all the other electrical nightmares that you hear about. So, catch it before it becomes a problem. So with doing that, what we're looking at here is we're looking at a complete circuit. So I'm looking at a battery and a starter. So what I've got going here is we're running, in short here, 600 amps going out of the positive connection from the battery, going to the starter solenoid, then from the ground starter back to the battery to complete a full circuit. So what you're looking at here, if there's any breaks here, the circuit's going to stop working on you. That's just the cut and dry scenario on it there. A couple of things that you need to look at when you are performing any kind of diagnostics on these pieces of equipment are, number one, start at the source. Start at the battery. The battery is the heart and soul of all electrical products. So if you don't have a battery in your products, then guess what? It's not working. So you got to start up with testing the battery. Then you've got to look at doing a voltage drop test on the cranking cables and the charging cables. So let's say our battery's good, but we may have an issue on say the cranking cables. So if I don't have the proper voltage going to my starter here, I'm not going to get a start. Then off to the charging cables. Well, if I've got a voltage drop issue going on in my charging cables, well, I'm not going to be able to have that ability to recharge my battery to make the process start again. And finally, we've got the alternator. So if your alternator is not putting the energy back in the battery that your battery is taking out, then you've got a faulty system.
And we're not going to dive too much into, we really wanted to point out these 3 steps, but we, like Celia mentioned earlier, you go back to your resource list widget to get a link on the last webinar where we talked about battery testing. But the main point here is you've got to follow these steps. Start with your battery, make sure you can deliver that power, to the starter, then the alternator to those batteries. It's just like, when I talked about the little test fixture. From the battery to the starter is just one leg of that circuit. So you've got to check each leg of that circuit.
Yes, definitely very, very important. So when you are doing any kind of battery testing, first and foremost, do a physical examination of the battery. Is it cracked? Is it able to even hold the electricity in it to do a test? So check the case. Make sure that the case is not cracked or busted. Number 2, check the posts. Is that if you don't have a good, and here's very important, guys, lead to lead connection on your posts here, you're not going to really accomplish very much. So let's say like you've got a lot of dirt or corrosion or something of that sort there. Well, right there, there's going to be a voltage drop right there because the connectivity trying to go through a bunch of grime and dirt and everything else that occurs out there, it's going to prevent a lot of stuff from happening for you. So just to kind of curb yourself from any kind of headaches on, chasing around the truck with a voltmeter, follow the proper steps on making sure that you're doing the job properly. Second, a state of charge is that, you don't want to start doing any kind of electrical diagnostics when you've got a dead battery. So you're shooting yourself in the foot by doing that. So make sure that the battery is at a full state of charge. And finally, apply a load to the battery. Make sure that the battery is going to be able to stand up to perform these electrical diagnostics before you really start diving into and chasing your tail by running a battery that just doesn't have any kind of capacitance to it.
So it looks like we got a question coming in from the audience. What causes batteries to explode? Well, one of the biggest causes, batteries at really cold temperatures, especially, discharge batteries at really low temperatures will freeze. So that's one of the main causes for a battery explosion. If you were to, try to jump start a frozen battery, that's not a very safe thing to do. So very discharged batteries, that's why it's so important to keep them charged. A very discharged battery will freeze at really low temperatures. So,
yep. Thank you. So what we see here on this slide is a couple of test equipment that a lot of you guys are probably familiar with. Is that, of course, you've got your old school carbon pile testers, that the old tried and true carbon pile. And then, of course, next to that one, you've got your carbon pile with the ammeter, so you can check, what kind of current is flowing through your system. Then right next to it is your the new autometer equipment. And the new autometer equipment, it is a lot easier to work with versus some of the old carbon pile testers. Now, a lot of people say, okay, well, the carbon pile testers are tried and true, well, that's what, my dad and your dad and everybody else's dad and grandpas used back in the day, which, you had to crank that knob right there for it to put the load on the battery. Then when you release the knob, it released the load. So whereas on the new equipment, you can just press a button on it and it applies the load automatically versus doing it manually. So the new autometer equipment is easier to use, but of course there's so much tester equipment out there, guys, that it's whatever's working best for you. But like what we always say here, these are the items that we recommend for when you are diagnosing and testing this equipment.
Going back to the your resource widget, we really explain that more in detail in the battery testing webinar. So go back to that. If you have any, certainly ask questions here, but there is a webinar that's dedicated just for this. So we have a question for the audience now. What is the maximum allowed voltage drop at 500 amps on the cranking circuit? First answer is half a volt drop. You got 3 volts, 1 volt, or a tenth of a volt per connection. So I'll give you a few moments to punch in your answer, and we'll review the results. A few more moments. Okay, so let's take a look here. 47.8% say a half a volt drop, 17% they say 3 volts, 13% say 1 volt, and 21% say tenth of a volt per connection. The answer is half a volt drop at 500 amps for the cranking circuit. Tenth of a volt per connection, I've heard that quite a bit. That's why I put this answer in here. But the answer is half a volt drop at 500 amps. So kind of going into, into applications, we'll start with truck voltage drop. And going back to that last question, TMC, which is the Technology and Maintenance Council, this is a group who creates recommended practices for the industry. It's a group of people who really dig deep and find out what the best practice would be for any application. But RP 129 states that a system is allowed a half a volt drop at 500 amps on the cranking circuit and half a volt drop at the alternator's rated output for the charging circuit. So it looks like from that last question, the majority of the group was correct. It's half a volt drop at 500 amps. So now we're going to kind of apply, you're talking about a truck application. We're going to apply this. So we got an electronic tester, we got a battery, and we have a starter, and we have that complete circuit. So you can see at the top here, we say no current flowing. And you remember in the beginning, I said, get it burned in your heads that you have to have current flowing before you have voltage drop. So we got our large leads on our starter positive post, our negative lead on the starter ground post. And again, a voltmeter reads the difference between 2 points in a circuit. So my red lead's reading 12.5, my black lead's reading 0 volts. So what's the difference in those 2 points? That would be 12.5 volts. Same thing here, no current flowing. I just change where I'm, put my leads in that circuit, whether it be your voltmeter or the voltmeter function on your electronic tester. I just changed my reference points. So now I'm at positive cable at the battery, negative cable at the starter. Got 12.5 on my red lead, 0 volts on my black lead. Same thing, I'm just measuring that difference, and that difference is 12.5 volts. Again, no current flowing. But now I'm just measuring my positive leg of that circuit. Going back to that project box and seeing each leg of that circuit, I'm just doing it on the positive leg. So I've got 12.5 on my red lead, 12.5 on my black lead, which is located at the starter. So 12.5 on both ends, the difference is 0 volts. Still no current flowing, but I'm going to measure the negative side of that circuit. So I got 0 at my battery, 0 volts at my battery, 0 volts at my starter ground post. The difference is 0. Now we're going to change it up a little bit. We're going to add current flowing to this system. And again, we have to measure 2 points in that circuit. So using my electronic tester, I'm going to put my large leads on my battery. I measure the difference there, and it's 8.5 volt difference. So I got 8.5 on my red, 0 volts on my black lead, my negative lead. So that difference is 8.5. Put my external volt leads, my smaller leads at my starter. And I read 7 on the red lead, 0.3 volt on the black lead. And my voltmeter is going to display 6.7 volts. So if I subtract those two numbers, I get a total voltage drop of 1.8 volts in that entire circuit. That's not going to, again, that's the entire circuit. It's not going to pinpoint exactly where that voltage drop is. But again, going back, walking around each leg of that circuit, we can figure out where that voltage drop is so we can fix it. So now, with current flowing, we're going to measure just our positive cable. So we're going to put our positive lead at the battery, negative lead at the starter positive post, and measure that difference. And I've got a 1.5 volt difference between those two spots in that circuit. Remember, half a volt drop at 500 amps on the cranking circuit. So we're already out of spec. So we look at the negative leg of that circuit. We've got 0.3 volt on my red lead, which is at the starter ground post, 0 volts at the battery. So that difference is 0.3. So adding those together, you get the 1.8 volt drop in the entire circuit. But going back, if I knew I had a cranking issue with this circuit, where would I start? Which leg of the circuit would I start diagnosing? It's where you have the most voltage drop, which would be your positive leg of that circuit. We had a 1.5 volt drop in that positive leg. So it's either due to connection problems, starting with the 1, 2, 3 step. Look at your battery post, make sure all your connections are tight there. All that creates voltage drop. It could be the wrong wire gauge. So make sure that the cable has the current carrying capacity to get that power where it needs to be. So again, in order to have voltage drop, you must have current flowing. And a voltmeter only reads voltage. So we got another question for the audience. What is the potential result of excessive voltage drop in a truck? First one is discharged truck batteries, starter failure, misdiagnosed alternator, or D, all the above. We'll give you a few moments to answer. All right, so we're going to go into the answers. 0% said discharged truck batteries. 3.4% said starter failure. 3.4% said misdiagnosed alternator. And 93% said all the above. The answer is D, all the above. When you're talking about discharged truck batteries, if that alternator can't deliver that power to those batteries due to voltage drop or poor connections, which causes voltage drop, those truck batteries are going to be jeopardized. Same with starter failures. Stuck contacts on the solenoid due to low voltage. All that plays a key role into how that, the life of that starter. Misdiagnosed alternator. If there's an excessive voltage drop in that circuit, and the alternator can't get that power there, it's not going to work hard. So if you're thinking that those batteries aren't getting charged, and you don't walk through the proper steps, you may swap out that alternator when it's a perfectly good alternator. So again, just to reiterate, go walk through those steps and make sure you start with the source, check your cables, make sure you can deliver the power, and you'll really get down to the root cause of the problem instead of swapping parts. No one has time to swap parts.
So on to liftgate voltage drop. So I know a lot of you guys out there, playing with the funnest item. Yeah, that's a word right now. The funnest item, our liftgate systems. So now we're going to look at doing voltage drop issues for liftgates. First off, got a question for the audience. What is the most common cause of liftgate pump motor or solenoid failure? 1 being overuse, 2, low voltage or voltage drop. Next is water intrusion or environment. Or finally, too much voltage. Give you guys a few minutes to answer that one. Okay. So 0% overuse. Low voltage drop, 88.9%. Water intrusion or the environment, 11.1%. Too much voltage, 0%, where the correct answer is low voltage and voltage drop, which is, guys, most of you answered that one absolutely correct. Low voltage and voltage drop in these solenoids and pump motors is a major super cause in the failures on these, because one, if you are operating these pieces of equipment here at a lower voltage, it's just like if you're looking at on a starter or any other kind of power hungry electronic equipment, that if you're operating at a lower voltage, you're increasing the heat in it, which increased heat is also going to cause increase in failure, which can cause many, many, many other problems.
Kind of add to that. The first, when I'm going in to see someone who's having battery problems, that's the first thing in a liftgate application, that's the first thing I ask is, how many pump motors are you going through? How many, liftgate solenoids are you going through? That's a tattletale sign of, what kind of, if you have voltage drop problems in your fleet.
So on to the charging circuit here is that what we're looking at here is I've got my large leads set up on a dual pole connection right here at the front of the trailer. And I've got my small leads that are connected to the liftgate batteries. So what we're doing here is that we're creating a load right there at the electronic tester to put a load on the entire circuit of the charging circuit, that is. So let's walk the leg here. So if I'm putting it on the battery side of my circuit breaker, is I'm basically walking the leg on this circuit. So right now what I'm looking at is I'm putting a load on this entire deal here, but now I've changed my small lead to the battery side of the circuit breaker. If we look at the next one, we're putting it on the trailer side for the circuit breaker. So as you can see in that previous slide here where we moved from one side of that circuit breaker to the other, we're just walking that leg on this circuit. So that way we can really find out and pinpoint where our voltage drop is occurring at. Is it occurring on the battery side? Is it occurring on the trailer side? So those are some few things that'll save you guys a lot of time out there instead of, just running a whole entire new harness on this thing here where you can say, okay, well, hey, I just needed a wire from this point to that point. Problem solved.
And you cannot do this. Again, you have to have that voltage reading. You got to know you got to have a reading of voltage to know where that drop is. You can't do that with a test light. So
exactly.
Test light's only going to tell you that if it's a complete circuit.
Exactly. So let's move over here to the pump motor. So what we're doing here is we're checking the output circuit. So what you've got to do on this one is that you've got to take off the positive cable from the pump motor. And the reason behind that there is, guys, is that using the pump motor on, as far as on the load side goes, is that you'll have so many variables in there. I mean, it could be the weight that's coming off of the lift gate, could be where the lift gate is powering up, powering down, several variables, several variables on that. So what we need to do is disconnect that positive cable off of the pump motor when we're doing voltage drop checks on our cables here. So again, I've got my big red lead right here on the output circuit. Of course, hooked to ground, small leads on the battery. So let's walk the leg on this one here. So I'm changing my small red lead to the battery side on the solenoid to check that cable. See if we see on this last one here where we move from the positive cable there to the solenoid. Now I'm going to move it to the next side on the other side of the solenoid here. So that way we can really diagnose if it's maybe a bad solenoid. Okay, well, if your voltage is proper on these points back here, but not when we get to that point there, you could look at, it could be in that cable coming from the pump motor, and it could be the solenoid itself. So it's just steady. When you're walking the legs on these circuits here, it's just a process of elimination. As I take it, from the source all the way to where that, power hungry circuit is at. So now let's look at doing a single pole. A lot of single pole applications are out there. So what I've got here is I've got my positive big red lead on my single pole, and of course I'm grounding to the trailer. Same concept, same principle, everything around, except I'm just using the frame to ground instead of just using the actual ground circuit on there.
The dedicated ground circuit for like in a dual pole application.
So we're looking at generic voltage drop. So what is voltage drop kind of summed up in a whole here? So if I'm looking at just a circuit here, so I've got a set of batteries, a circuit breaker, and my load there at the end, which I'm using the load, basically the electronic tester, to basically use current to make it work, is I'm creating generic voltage drop. So I've got my small leads here on the battery. I've got my large leads connected to the end of that, and I'm using an electronic tester to put a load on those. So I'm basically just trying to tell what the difference is from point A to point B on that to find out what my actual voltage drop is.
Yeah, just kind of add to this, you can do this on any circuit, not just kind of narrowing it down to a truck application or liftgate application, any circuit. But again, you have to have that load, which that electronic tester provides. Or, when you're, trying to learn and grasp the concept of voltage drop, this board's the same thing, my light being the load, and then just walking around that circuit with the voltmeter to see where that drop is.
Yep. And guys, we've got a super promotion right now. Got a webinar only promotion. We're doing our meter kit for $189.99. Make sure that you use your code WebinarJF and contact your favorite Purkeys rep. Anybody that's close to you or any of us, we're all the same here. And definitely, guys, take advantage of this right here. I mean, that is a super price for what you're getting out of that set there. So definitely take advantage of that one right there. Also, if you haven't yet, sign up for the newsletter. Is that we're also, like Celia said earlier, we're going to send you over a copy of the entire webinar. So don't feel like you got to get your smartphone out right now to scan the QR code or anything of that sort there. But sign up for our newsletter. You get all the latest and greatest, updates that we're doing on different things here. Many educational things. Guys always tell it, definitely use it for the educational purpose. I mean, that's definitely one thing that I always tell everybody. I'm sure many of you that met me before, you've always heard me say, education, well, that's something that nobody can ever take away from you. So also you can go to www.purkeys.net to sign up for the newsletter.
And before we go into here at the end, we're going to ask, see if the audience has any questions. You get a chance to ask us, anything you might want to ask. But wanted to mention that July 25th, we have our next webinar on alternator testing. So make sure you sign up for that. And there'll also be a little survey at the end that you can kind of let us know how we're doing and any topics that you might want for future webinars. Again, this is for you, for the audience to help you with your skills, any problem areas with your fleet. Electrically, that's what we're here for. So make sure you fill out that survey, and we'll take a look at that and definitely consider it for next webinars. Does anybody have any questions? We haven't seen any pop up yet, so we're gonna
questions or comments.
We're gonna hang out here for a bit, and please, we love questions, so please fire them at us. Again, if you didn't have any time in your busy schedule today, again, these are all recorded, so make sure you go back, and at any point in time you want to brush up on your skills, make sure you go back and look at these videos. We have tons of them on there. So,
and feel free to reach out to us anytime.
Okay, we did have a question come in. So how can we check a battery without a load test? Again, without kind of going back, without any kind of load, all you're reading is open circuit voltage of that battery. So if it's a dead battery, the only thing you're gonna be able to tell is if it's a dead battery. So in order to properly test or diagnose, you got to have a load.
Yep.
Next question: do you sell or recommend a short finder? No, I know we don't sell anything like that, but feel free to email us or reach out to us afterwards. We'll do some checking for you. How does a battery? The next question is: how does a battery blow up in the summertime?
Probably overcharging when the battery's just the gases can't escape it or anything of that sort. There, it's going to, of course, when the gases increase inside of a battery, it's got to find some way to escape, and generally the weakest point on that battery is where it goes pop.
And going back to one of the slides that Tim went over on physical examination too, one of the biggest things to look at too is for a bulging battery.
Yep.
Discard it. Don't properly discard it, but it's very important to take care of. That's where that power is coming from. So it's very important to maintain that battery. The worst thing anybody could ever have done is put maintenance free on batteries. Nobody ever looks at them. So you got to maintain batteries. You got to take a look at them every once in a while, during your PMs, and make sure they're properly maintained. So we do got another question. So an alternator can overcharge the battery and cause it to explode. I'll have to get back to you on that. I don't think an actual alternator could overcharge, but again, going back to the gases can escape. We'll reach out to you on that one, but the next question is: the smaller leads always put on the battery when doing a voltage drop test? Why don't the larger leads go on the battery? It really doesn't. I don't think it really matters. Again, we're talking about measuring 2 points in that circuit.
That is the one difference between one point and the other. And generally, where your larger leads are going to go is going to be on your current bearing circuit. So, like where we saw in that slide earlier, where we just had the small leads on the battery and had just the load tester on the other end. Well, that load tester was what was creating the load for the batteries to deliver the power to the load tester.
The next question is: what meter were you using in the presentation that had 4 LEDs?
4 leads.
Oh, I'm sorry, 4 leads. Trying to think of the.
I would assume it'd probably be the tester.
The electronic tester. So that would have been a BVA, an Autometer BVA 2000 or 2100, which is one of your higher end load testers versus the handheld. Again, it's really all about resolution. The BVA versus the BCT models of Autometer testers. You're going to get more of a load out of the BVA benchtop tester versus the BCT handheld tester. So next question is: how do you get a voltage reading going from positive to negative terminals on the battery? How do you get a voltage reading? Make sure I understand that question. You have to have a voltmeter.
Of course, you got to have voltage in the battery.
Right.
And the battery has to be charged. So,
and you're measuring, again, a voltmeter measures the difference between 2 points in a circuit. So got my red lead on, from my voltmeter, got my red lead on my battery, positive, black lead on the battery, negative. That voltmeter is going to display the difference between those 2 points. So I'm going to have a voltage reading on my positive side, 0 volts on my negative side, and it's going to display that difference. So the next question: load testing a battery, 625. I'm assuming that's CCA, cold cranking amps. How amp load and how long?
I would guess how much of an amp load and for how long?
How much an amp load?
Well, I know you'd want to load test it at half its cold cranking amps for up to 30 seconds when you're doing the actual load test on that. Is the general
rule of thumb.
Yes.
We can reach out to you, with more detailed answers on that.
Thoughts on the Load Pro test leads for a multimeter?
Don't have any experience with that.
Yeah, I don't either. I couldn't answer yay or nay on that one. Safe to work on batteries in the rain? In the rain, I guess you'd have a little bit more prone to slippage, from if you're trying to tighten something under there. So is disconnecting the negative battery cable really good for checking the alternator? You got any kind of experience on that one?
Disconnecting the negative battery cable really good for checking alternator.
I've not had any kind of experience on unhooking the ground from there to check the alternator. So I couldn't tell you on that one.
All right, great questions, guys. Thanks for if we didn't answer your question thoroughly, please reach out to us. We'd be happy to go into a little more detail. But hopefully this was very helpful for you guys and girls. We're excited to present this to you today. So thanks for attending, and join us next time for the next webinar.
Thanks a lot, guys.